moving on to 3.2, and today we will learn how to represent a function. So let's quickly define what a function really is. So let's write this big word down, function. Well, the book definition, you know how it is with the book. It's quite lengthy. It basically says that for every input there is an exact output for that. Okay, so let's just quickly write that down. Input, that means your x. There is, should I say, exactly one. Output. Okay. Now my definition for a function is that if I have to give a command, here's just an example, a side example, so hopefully you can remember it. If you just say, if you issue a command to, let's say, your phone to dial a number, let's say you dial 5, okay, what do you expect to see on the screen of your phone? Shouldn't you be seeing a 5? Yes, right? So that to show that your phone is functioning. Notice I'm using the word function. Functioning correctly. Imagine next time you enter a 5 into your phone and you obviously expect to see a 5. However, you don't. You see a 6. That shows that your phone is not functioning correctly. I'm emphasizing the word not functioning correctly. So if you think about what I just said, to really summarize it, it just simply means for every input that I give, I expect to have that same output every time. If I give you an input or a command, I expect you to do that exact action every time. But if you're doing something different, giving the same input, then something must be wrong. So the way, remember the last lecture that I asked you to go ahead and observe the difference between the two mapping diagram versus two graphs, one is a function and one is not. I hope you see the difference. If you don't, I will show you that today. So let's start with a quick example. Maybe before that I just want to define this word as well. Vertical line test. VLT, short for VLT. It's just a way to test whether something is a function or not. Okay, so a way to test whether something is a function or not. And this vertical line test, if you can use your finger if you want to, whatever you want. But if you draw a line straight through, and if that line only intersect or cross over your graph at exactly one point at a time, then it is a function. I'll demonstrate that right now. So let's take a look at a quick example. Imagine I have this relation right now. I have -4, 5, -3, 2, -4, 6. Oops, I kind of messed up there with my sign. And 2, 4. Okay, so these I have 4 points. Let's do a quick table. Of course, a table doesn't tell you the whole story, but a mapping diagram definitely will. But I'm going to show you all 3 different ways to represent it. So here's my table. I have 2, 4. Notice I'm trying to rearrange it. 3, 2, -4, 5, and -4, 6. If I'm doing a graph, your graph will look something like this. -4 on the left, because I'm going to the left here. -4, 1, 2, 3, 4, 5 up, so -4, 5. +3, 2, 3 right, 2 up. -4, 6, so that means I'm going 4 left and 6 up. And I have 2, 4. So 2, 4 is right here. Okay, so this is the representation of the relation on the graph. For the mapping diagram, very similar to my table here, but I just represent it differently. I have, notice I'm seeing, let's see, I'm seeing the -4 representing twice, so I only need to write it one time. There's a 2, there's a 3. Notice the x stays with the x side, right? And for the y side, I have 2, 4, 6, 5. So 2, 4, 5, and 6. Okay, so let's start mapping. I have -4, 5. There you go. I have 3, 2. There you go. I have -4 and 6. Okay, so there you go. And I have 2, 4. There you go. So I want you to look at this very carefully. Notice how -4 having 2 lines coming out of it? It simply means that this same exact input, just like I told you, one single command, I should expect to see the same thing over and over, right? If I issue the same thing over. However, for -4, one time I get a 5 back, and another time I get a 6 back. So that's 2 different outputs for the same input. That is unacceptable. Just like your phone. If I issue a 5, I should see a 5. I shouldn't be seeing another number if I press a 5. In this case, it shows me that if I press, if I input -4, I don't get the same input back. I get different outputs. So that's not how we want to have it. So this is, this to show you that this is not a function. Okay, so when you do a mapping diagram, it's a lot easier to see it because you see that you have 2 lines coming out of the same input. On a map, on the graphing side, if you notice remember I said the vertical line test? How do we know when something is not a function? Well, here it is. Watch. If I'm doing a vertical line test to every single point that I have here, here's a vertical line test. Ooh, it's crossing only 1 point. That's crossing only 1 point, so it's still a function, right? However, when you get to here, it's crossing over 2 points because the vertical line is crossing over 2 points at a time or more. This to show you once again that this is not a function. Okay, so we have different ways to represent the same thing. Now, even if I don't graph or do a mapping diagram, I can quickly see that this is not a function because of this right here. Repeated, see it? Repeated input giving 2 different outputs. That's another way to spot it right then without having to do any extra work. Okay, so let's try to do another example to show you that it is a function. So pretend, once again, here's my relation. I have 4, 3. I have 2, 3. I have 1, 0. So just make it short for now. And I'm just going to quickly show you this on a graph and do a mapping diagram instead. So 4, 3. Here's 4, 3. Here's 2, 3, and 1, 0 right there. So hopefully by just looking at the graph, imagining the vertical lines going through, notice it's 1 point at a time. So yes, it is a function, as you can see. I'm graphing, and I'm seeing one line, vertical line, crossing 1 point at a time. So that is definitely, yes, a function. Okay? Now in a mapping diagram, what does it look like in a mapping diagram? Well, it looks like this. 1, 2, 4. Here's my inputs, 1, 2, and 4. Here's my output. I got 0 and 3. 3 is repeated, so I only need to write it one time. Here's my mapping. 4 to 3, 2 to 3, 1 to 0. Now notice the difference between this particular example versus the other one. This time I have 2 different inputs, 2 different commands going to the same exact output, same result. That is actually acceptable. For example, if you're typing on using Word document, a document on Microsoft Word, is it okay? How many ways can we actually delete a line of text? So many ways, right? To end with the same result, you can actually highlight it, do a delete, highlight it, right click, cut. So many different ways to arrive to the same result. So in this case, it is acceptable to have different inputs go into the same output. Okay, so it's just to keep that in mind. Please view my next video for the function notation. I'm going to stop this for now just to show you how to recognize a function. Okay, so continue on my second lecture of this.